In this lesson, we are going to take a look at the Pythagorean Theorem. You might remember this from future or previous math classes with the Pythagorean Theorem, which is a squared plus b squared equals c squared. Now you might be wondering where the a, the b, and the c come from. Well, if we take a look, we can only use this with right triangles. So if we draw a diagram, go ahead and draw your own diagram of a right triangle. The A and the B are your legs, and it doesn't matter which one is your A and which one is your B. One of your legs is your A, and the other leg is going to be your B, and you could have flip-flopped those, and that's totally fine. And the legs are your shorter side of your right triangle. I like to think they're the ones that are touching your right angle. Your C always has to be your hypotenuse. Okay? And we know it's the hypotenuse because it's the one that's across from your right angle. And generally it's the longer side or the slanted side. So again, your legs are your A and your B. They're the sides that make up your right angle. And the C always has to be your hypotenuse. Again, that's the longest side. Okay? It's the one across from the 90-degree angle. If we take a look at some examples, we want to find the missing side of these right triangles. And you can use the Pythagorean theorem to find the missing side of a right triangle. Okay? So go ahead and label. Again, the side across from your 90-degree angle always has to be your C. So what I like to do is start at my 90-degree angle, I go directly across from it, and that I label my C. The other two sides, it does not matter. I'm going to make this one my A, and I'm going to make this one my B. Again, it does not matter which leg is your A or your B. You could have made 6B and A3. It does not matter. The one that does matter is the hypotenuse, and that has to be your C. So again, it's at the top of your paper, but I'm going to rewrite it up here. The Pythagorean theorem is a squared plus b squared equals c squared. So all you have to do is just plug those values into that theorem. Something like this. Well, we've labeled our A as 6, so we're going to write 6 there. We labeled our B as 3, so we're going to write B there. And then we don't know that side, so we're just going to label it as C. Right? And sometimes there's an X written there, so you just fill in an X. And then clean it up. And you can just use your calculator. So if you plug this in your calculator, we have 6 squared, which is 36. 3 squared, which is 9. And again, we just leave that as C squared. Again, keep cleaning it up. Go ahead and combine your like terms. 36 plus 9 is 45. C squared. And we just want to know what C is. We don't necessarily need to know what C squared is. So we're going to go ahead to get rid of that square. All you have to do is the opposite. So the opposite of squaring is square rooting. So when we square root both sides, this C, the C squared, just becomes a C because I got rid of that exponent. And we're just left with the square root of 45. Because 45 is not a perfect square. So you maybe tried to plug that in your calculator, and when you do, it's going to give you a long, ugly decimal. Okay? Sometimes you can just round and leave it as a decimal. In this instance, we want to leave it as the directions say in simplest radical form. So you kind of have to think back to your Algebra 1 days. What you're going to need to do. I like to use, there's multiple methods to simplify radicals. I like to use the largest perfect squares method. So somewhere I would write it at the very tippy top of your paper. I'm going to write it right here so we can see it. But you're going to make a list of the first 10 perfect squares. If you don't know what those are, you just have to plug in your calculator. So in your calculator, you can just do 1 squared, and that gives you 1. And then you can do 2 squared. That gives you 4. 3 squared gives you 9. 4 squared gives you 16. 5 squared gives you 25. 6 squared gives you 36. 7 squared gives you 49. 8 squared gives you 64. 9 squared gives you 81. And 10 squared gives you 100. Okay? I'm going to go ahead and copy these for later. Okay? So you have to, when you simplify, you have to find the largest perfect square that can go into 45. So what I like to do is start with the one just under 45, which is 36. Okay? 36 cannot divide into 45. That doesn't work. So try 25. 25 does not divide into 45. Try that out. Try the next one. If you do 45 divided by 16 in your calculator, it doesn't work. Okay? So try the next one. 9. When you do 45 divided by 9 in your calculator, it gives you a whole number. That whole number is 5. So that's what you're going to write in your other radical. Okay? Well, to keep simplifying, the square root of 9 is 3. You cannot take the square root of 5, so you just tack it on at the end. Okay? Sometimes you will have to leave your answers in simplest radical form, and that's how you do it. And we'll see that again in number 2. Sometimes the directions say round to nearest 10, and you don't have to leave it as a radical. You can just plug in your calculator and round, and you will see that here in the next section of examples. Okay? We can do the same thing in problem number 2. I'm going to go ahead and draw a line and divide up these problems. In problem number 2, it's the same exact steps as problem 1. Start with your right angle, go directly across, label that your C. Doesn't matter which one you make your A or your B. I'll make that one my A, that one my B. You can just flip-flop them. And then, again, go ahead and plug those values into the Pythagorean Theorem. So we're going to do A squared, 4, plus our b squared, which is 8, is equal to, we don't know what our c squared is, so just leave it as c squared. And then go ahead and just clean that up. We're going to do 4 squared is 16, 8 squared is 64, we have no idea what c squared is, so we just leave it as c squared. 16 plus 64 is 80. And again, to get rid of that exponent, we have to do the opposite. So we're going to square root both sides. When we square root c squared, it makes the exponent go away, so we're just left with c. And 80 is not a perfect square. You might try to take the square root of it in your calculator. It gives you a long, ugly decimal. So we're just going to leave it as radical 80. And always check and see if you can simplify using that same exact method we did in problem number 1. We have to find the largest perfect square that can go into 80. And we're going to use that same list we just wrote here. You probably wrote it at the top of your paper. So we're going to start with the perfect square that's just under 80, which is 64. We're going to go down our list. 64 does not divide into 80. So we're going to move on to the next one. 49. You do 80 divided by 49, doesn't work. 80 divided by 36, doesn't work. 80 divided by 25, doesn't work. But when we do 80 divided by 16, we get a whole number. And that whole number is 5. And keep cleaning it up. The The square root of 16 is 4. Can't take the square root of 5, so we just leave it as radical 5. And there you go. And if you need to see this again, feel free to pause the video, re-look over these problems if you need to. Okay. And if you need to finish writing stuff down, go ahead and pause, because I'm going to move on to the next set of examples. So we look at 3 and 4. Again, we're going to find the missing side of this right triangle, but it's nice because this time we can round. We don't necessarily have to worry about simplifying those radicals. And if you notice, some of the parts are decimals already, so that's a good indicator that you're not going to have to simplify the radicals. You can just kind of plug everything into your calculator. Okay, so again, we're going to use the Pythagorean Theorem. This should already at the top of your paper, but I'm going to rewrite it so you get a visual. Okay, so again, label. Start with your 90 degree, go across, label that your C, and then label your legs A and B, and again, it does not matter. You could have labeled this bottom one A and 3.9 B, that's totally fine. Okay, plug your values in. So we have A squared first, which is 3.9, plus our B squared, we don't know what that is, equals our C squared, which is 11. You're going to go ahead and plug 3.9 squared into your calculator, whatever type of calculator you're using, and it should give you 15.21. Don't round until the very end because we want the most accurate answer as possible. So wait till the very end to start rounding. Plus B squared is equal to, again, 11 squared, you plug your calculator is 121. This is a little different than the previous ones because on the previous problems our C's were missing, so all our numbers were on the same side. In this problem, our numbers are on opposite sides, so we just have to move this 15.21 over so that the B squared is by itself. And we move it over by doing the opposite. We're going to subtract 15.21. That way it cancels, and we're left with B squared. And 121 minus 15.21, 105.79. Just like the other problems, we're going to go ahead, square root both sides. That way we just have B. And now this is where we can round. Again, don't say the rounding until you take the square root. We're going to take the square root in your calculator and 105.79. It gives you 10.3 when you round. So when we round to the nearest tenth, that second number bumps that 2 up to a 3. And again, we take a look at how to plug this in your calculator. Mine's a graphing calculator. If you're using a scientific calculator, similar steps. We'll take a look. There you go. When you do plug this in your calculator, you're going to do second x squared. With any calculator generally, you hit your inverse or your second button and hit the x squared, and that gives you your square root. And then you're just going to do 105.79 and hit enter. So you can tell that's a big, long, ugly decimal. The directions say round the answer to the nearest tenth. So whenever you're asked to round to the nearest tenth, that's 1 decimal place. Well, if you notice here, it's 10.28, so that 8 would bump that 2 up to a 3. So that's why your answer is 10.3. Nice when we can round, we don't have to worry about simplifying. We have one more example to do together. Same exact steps. Go ahead, start at your 90 degree, go across, going to be your C. The other two do not matter. One's going to be your A. The other one's going to be your B. Again, the bottom one could be A. The up and down one could be B. Doesn't matter. You're not wrong. As long as the hypotenuse is your C. Okay. And plug it into that theorem. A squared plus B squared equals C squared. So we're going to do 3.6 squared plus B squared equals 7.4 squared. To 3.6 squared in your calculator, and it's going to give you 12.96 plus, again, we don't know what B squared is, so we leave it as B squared. And then we're going to do 7.4 squared in your calculator, and that gives you 54.76. Just like the last problem, we want to get that variable by itself, so we have to move over this 12.96. So we're going to subtract it on both sides. That way it cancels. We're left with B squared is equal to, when you subtract that in your calculator, it gives you 41.8. And again, do not round to the very, very end. We want the most accurate answer as possible. To get B by itself, we're going to go ahead and square root. That gets rid of your square. And when you plug this in your calculator, you're going to do second or inverse, whatever type of calculator you have, x squared, wherever that is on your calculator. I have a graphing one. And then type in that number, 41.8, and hit enter. Okay? So again, we want to round to the nearest tenth. That's one decimal place, so we have 6.4. Look at the number after it, that's a 6. That 6 bumps that 4 up to a 5. Our B will be about 6.5. Now, okay, if you're having issues with your calculator, if you're not using your graphing calculator, and you don't know where to find the square root button or the square button, please make sure you ask your instructor, and they will be happy to show you.